Okay, so we're here today to discuss combination circuits. First, to bring you back to where we started from, we have to go back to Ohm's law, and we have to go back to series circuit and parallel circuits, because a combination circuit is the combination of those two things, right? So when we bring you back to series circuit, we have to remember that ET is equal to V1 plus V2 plus V3, etc., right, to give us the sum total of voltage. Or our resistance total is equal to R1 plus R2 plus R3, right? And that will give us, etc., to give us a resistance total. And our I total is I remains the same throughout the series circuit, right? So IT is equal to I1, I2, and I3, right? And in a parallel circuit, as we remember from before, right, it's the sum of, right, 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3, etc. All 1 over to give you a resistance total there, right? And our voltage is V1 is the same as V2, V3, etc., right? Because they're in parallel, the voltages stay the same, and in a series circuit, the voltages drop off, and we have a voltage drop in H, right? So to get into a combination circuit of that, right, we have in series, then parallel, then a series circuit, right? So if we adjust a number here, this is a very simple circuit, we know that when we break down this resistor, this parallel resistance, if we break it down, and it's a very simple one to do, it's a number of circuits divided by itself, and that will equal to 1 ohm. That becomes new now as a 1 ohm resistor, right? Because this is canceled out, this is canceled out, and represented by a new number, right? If we put a value in here of 10 volts, right? And we add up these series now, we have a current flowing of 2 amps, right? Which gives us 4 volts there, and 2 volts there, and 4 volts there, which gives us a total of 4 plus 2 plus 4 equals 10 volts. And that's how it's balanced out. So everything will balance out. All the numbers will match and line up, and it'll be a smooth transition by shrinking this, making it one resistor, fitting it in, making it all series, and dropping it down. Now, we follow 2 laws by this, and that's one's Kirchhoff's voltage law and Kirchhoff's current law, right? The total number of voltage, according to Kirchhoff, is that the sum, if we had 20 volts here, 20 volts here, and 20 volts here, the sum of those voltage drops will be the total sum of the circuit. So ET example here would be 60 volts. As far as Kirchhoff's current law, if we had 1 amp flowing in here, 1 amp flowing in here, and 1 amp flowing in here, we would have a total of 3 amps flowing, because this is 1 plus 1 and plus 1, and that would equal to our 3 amps flowing in that circuit, Kirchhoff's current law. So, as we get through here, we have a little bit more complicated circuit, right, that incorporates all the values that we need. In our first circuit, we don't know the total voltage, we don't know the total amperage, we don't know the total resistance. So those are all things that we want to find out. So how do we start finding what we want, right? Well, first of all, we have to find 2 numbers that give us part of the equations of Ohm's law, which is E is equal to I times R. The only place in this circuit that gives us those two references that we have is that we have an amperage here in a parallel circuit at R5, which is here, and that's 1.775 amps, they tell us, and it's over a 3 ohm resistor, right? So all those resistors are exactly the same ohmic value, right? So that ohmic value, we'll find out our amperage that flows through here, right? So we have to add 1, 2, 3, we have to times that by 3, and we get an ohmic value of, or an amperage through this circuit of 1.775 plus 1.775 plus 1.775 for a total average. Does anyone have a calculator there?
5.325 amps.
5.325?
Yep.
Amps. So we have 5.325 amps flowing there, right? And for this answer here, we have 1.75 amps flowing, 1.75 amps flowing, right? Perfect. Okay, so anyway, we have an amperage that flows now through here at 5.25 amps. So in a series circuit, which is this now becomes a little bit of a series circuit in here, right? We know that we allow 5 amps, 5.32 amps flowing through here, down here, and we'll have a voltage drop here, right? So voltage drop, of course, well, we got to find V is equal to I times R, and we'll have a voltage drop here of 5.25 amps times 5 is equal to, anyone got a calculator up?
26.625.
26.25?
625.
625?
Yeah.
625 volts. So we want to get that answer there. That's 26.625 volts. And we already know the R value there, which is 5 ohms. And the average there, of course we know, is 5.325. That tells us this. But we have to drop this down into one resistor here. So we have three resistors of the same value, right? So we can divide that by the number of the resistors, right? To get a total ohms value for R5, R6, and R7, and that will be equal to 1 ohm. 1 ohm times this, right? So our V, R5, 6, and 7, because they're all in parallel, the voltages will be the same, right? Will be equal to 1 times 5.35 amps, which is equal to the voltage of 5.325 volts, which gives us a total voltage, a drop here, plus this drop here, so it's 26.625 volts at R and VR4 plus VR5, 6, and 7. That's 5 volts, 5.325 volts, giving us a total value in this side here of
31.95.
31.95
Yeah.
volts. And this would be a total of 6 ohms 1 ohm here plus this 1 ohm gives us a new value, or a new resistance over here, and this resistor would be called our 4, 5, 6, and 7, right? So now, we're on this side. We have 3 circuits in parallel. R2, R3, R4, 5, 6, 7, right? So we can go the 1 over, right? So we want to go to R total. 1 over R total is equal to 1 over R2 plus 1 over R3 plus 1 over 4, 5, 6, 7. Do you follow me?
Yep.
Okay, sorry for that little bit of an interruption. So now we're in a place here with 3 resistors in total, in parallel, right? And we want to find the total resistance of the new resistance at this point, right? So how we find that is 1 over RT is equal to 1 over R2 plus 1 over R3 plus 1 over R5, 4, 5, and 6, and 7. So if someone can put that in their calculator real quickly and give us an ohms value at this point.
At that point, it's 1.09.
1.09?
Yep.
Ohms. Perfect. And then what we have now is this is the new resistor of R2, R3, R4, R5, R6, and R7. So this covers all this resistance here, and now we're in a series circuit, right? So we're in a series circuit now, and they've given us 1 ohm, 1.09 ohms, plus 1.91 ohms will give us a total resistance value of RT is equal to, in series, we add them together, what's the total RT?
4.
4 ohms. Okay, so now we found RT is equal to 4 ohms. We still need amperage here. So we have a total voltage in here, which is the voltage is, what was the voltage here? It is
26.
5.325
That's the amps.
plus
Total voltage is the 26.325 there.
plus 26, so our total voltage here, and we said it was before, is 30 point,
3195.
Oh,
3195.
What is it?
3195?
3195?
Yeah.
Perfect. And how did we get there? We've added up these 2 voltages. These voltages are now in parallel, right? So they would be equal against R3 and R2, right? Everyone follow?
Yes.
Perfect. Okay, so if we wanted to find the amperage down here, we would take our voltage, which is at 31.95, divided by our resistance here, and we get 31.95 divided by 4, which gives us
7.9875.
7.9.
7.9875, so it's pretty much 8.
I'll call it 80 amps, right? If we have the voltage there, because it's the same as 31.95, and we went across resistor 2, what would be our average down there?
15.98.
15.98
0.98.
amps. Okay, and our resistance value is 2. Our resistance value here is 4. So we're getting all the answers now, right?
Yeah.
So we have a voltage drop across here of 31.95 volts. Everyone agree?
Yeah.
So we should get an amperage reading. If we have 1.09 ohms there, and we divide that into 31.95, we should get an I, our amperage, flow down this line.
Yeah,
And what is the average?
29.3,
29?
0.31.
29.31 amps.
Yeah.
So if it's in a series circuit, if it flows here, it will flow here. We'll have a voltage drop here, and our amplitude will be the same. It will be at 29.71 amps.
0.31.
0.31, sorry. 0.31. And we'll have a voltage drop of 1.91, which is stated value, times 29.31 amps. What is our total voltage drop here?
55.98.
55.98
0.98. Yeah.
volts. And we're in a series circuit still, so that's flowing that way. This would be, of course, our I total. We'll have a voltage drop here of 29. And since it's only 1 ohm, it's pretty easy to do. It's 29.131 amps, right? So we have a voltage drop here, or sorry, volts. So we have a voltage drop of 29.31 plus a voltage drop of 31.95 plus a voltage drop of 55.98 volts, and we have a total voltage of that whole circuit of
117.24.
117.24
Yep.
volts. And that's how we break down a combination circuit and put in our values. Thank you very much, and we'll have some worksheets later.